So one thing we can do, that's one thing, right? Okay. What's another thing we could do?
Since they're added, they have to be multiplied, like the things that are in parentheses.
Okay, so you're saying this addition, we could, we've got an addition of two log expressions, right? Now the only problem is, as it's written, we have to do this before we can do that, right? So let's just stick with what we can do with this. But we see that there's a plus of two log expressions, but it's not exactly like this because we don't have anything that allows for some number to be out in front of the log, do we? Okay? Now you see, since we've done this, that if you do this first, then you could apply this rule. Okay? But we can't do it yet. So let's just stick with what we can do here, but that's exactly kind of the other direction we can go with this, okay? So, is there anything we can do with this? Can we rewrite the log of xy squared in any way?
Log x plus log y squared.
Yeah. We got a log of something times something, right? So we can write it as a log of the something plus the log of the something, right? So we could write this as log x plus log of y squared, right? That's certainly an option. Now we can't apply this to this expression. Yeah, we can't bring that 2 out in front here by this law because this law doesn't address what happens if we have something multiplied by a to the p, right? Okay? And I've seen people do that. Now that, on first exposure to this, if you did that, make yourself a note why you can't do that, because it doesn't fit the form of the rule. Okay? You got to interpret the rules very literally. If the rules don't justify it, you can't do it. And remember, and nobody completes a pre-calculus course without still doing some stuff by superstition, but we're trying to stamp out as much as we can. Okay? In other words, superstition is something that you haven't bothered to justify by the laws because it looks like it ought to do this. Okay? You're used to being able to bring a power out, so you look at this and you bring that power out, right? Without stopping to think that that's not what the rule tells you to do. Well, we all do that. It's very easy to look at it and say, okay, that ought to work. Do it without checking it against the rules, okay? You got to check what you do against the distributive law. You got to check against all the other laws. If you do that, you won't try to get rid of a multiplication in an equation by subtracting one of the things that's multiplied, right? You'll do it by dividing and so forth, okay? And forget that cancellation thing, which I've forbidden for the whole course. It's the one thing on that preliminary assessment that nobody that I've seen in any dual enrollment pre-calculus class at the beginning of their course did right. Everybody did wrong calculation. The average on that one problem is a fat 0. Okay? And these are people who, on the whole, doing pretty well in their pre-calculus course. We've already assessed their pre-calculus 1, and results are fairly encouraging. Okay? And yours are going to be too. Okay. So these are smart people, but somehow they aren't canceling right because they are not doing math by rules. They're doing it by superstition. Okay? Not sure how to fix that problem. You all are less superstitious than you were when we started. Okay, so let's go back to anti-superstition. What else can we do here? Well, there's really nothing else we can do by single application of the laws, is there? Okay? But we see that there are things that we're going to be able to do now that we've done this. Like having done this, we'll be able to rewrite this in such a way that we can apply the first law. And having done this, we can apply the second law to this expression, right? So now we come down here and we can say, okay, one thing we could do, a log x plus log of xy squared equals log of x to the a plus log of x plus log of y squared. We could write it like this, right? Now, we could then say that this is equal to, well, if we've got three additions, then we can bring those inside the log and change them to multiplications, not by superstition, but by careful application of this law, right? So I could say that this equals, well, let's do it carefully. Let's do this. This would be the log of what? Log of x times x to the a, right? Because we have a log of one thing plus a log of another, we can do this. Okay? So now this equals what? Well, log of this plus the log of this is a log of this times this. Log of x times x squared times y squared. Okay? And of course, what's, and it's not x squared, it's x to the a. What's the log of x times x to the a?
2x to the
Sorry?
2x to the
Couldn't hear.
a. 2x to the a.
No, no. That would be x to the a plus x to the a would be 2x to the a, right?
Yeah. Sorry.
You multiply powers of the same base, you're going to add the exponents, right? What's the exponent of x?
1.
And what's the exponent of x to the a?
A.
Well, duh. Yeah, a, right? So you're going to have 1 plus a, which I'll write as a plus 1 because we usually put the letters first and then the numbers, right? We're adding, we're subtracting. Okay? So that's one way to rewrite this. Okay? Now, another way that we could have rewritten it is to just break everything down. We've brought everything into one log expression here, right? And that's one thing you're going to be asked to do. Here's a series of additions and subtractions and multiples and stuff. Write it as one logarithmic expression. Okay? The other thing is, break it apart as much as you can. Write it as a sum of as many and differences and multiples of as many logs as you can. And if we did that, we would write this. We have a log of x plus a log of xy squared. We're not going to write this as log of x to the a because we're trying to break it down. It's already broken down. That would be, going the opposite direction. And you want to get used to this. But your text has a lot of good examples if you need them. You can find examples online. But I think if you understand what we're doing here, you might not need them. So that's a log x plus log x plus the log of y squared. And now what can we do? Well, we could write this as a log x plus log x. Of course, that would be a plus 1 times the log of x, wouldn't it? Not going to go there right now, but that would then be plus 2 log y. Okay? And then a plus 1 log x plus 2 log y. I'd be almost happy. I'd be happy if you got to this, but not happy enough to give you full credit. 9 out of 10 maybe. But for that last point, separate the A's from the B's. You know how to do this, okay?